Let's go ahead and get started. All right. Hi, everybody. I'm Guy from DataStack Academy. Today's webinar, we're going to talk about Jupyter for data engineering. And in particular, the Jupyter project contains these really neat code notebooks that we're going to do an interactive demo. So the overview of today's presentation, we're going to talk a little bit about data engineering in general and as a career. And then we'll talk a little bit about the Jupyter project and Jupyter Notebooks and why as data engineers and data professionals, we use notebooks on an almost daily basis. And then we'll do some hands-on demo with a Jupyter Notebook to take a look at some Python and Pandas and some Google Cloud things for working with data. And then at the end, we'll talk a couple minutes about a little bit more about DataStack Academy and what we do. Okay, so first let's take a look at data engineering, just a little bit of an overview about data engineering as a career. Here's some statistics that you can see. So these numbers come from the Birchworks survey of data professionals, several hundred professionals in 20 and 21. So you can see the top number here is over 80% of companies plan to apply or plan to hire more data engineers this year. This is a really striking statistic. We're really passionate about data engineering, and part of that is because data engineering is pretty much the hottest field in tech right now. Companies have a lot of data, volumes of data are increasing every day, and there's a lot of demand for people that have the skills to work with that data. So just about every company is, okay, let me make sure I'm sharing. Yeah, I think I'm sharing. CJ, you don't see it? It says I'm sharing. Okay. And okay, so next statistic here is from some job numbers on Indeed related to data engineering. So you can see here average data engineering salary, 119K per year. So to put a little bit of a finer point on this, intro data engineers typically make high 5 figures, low 6 figures. Level 2 data engineers commonly make 130 to 165K. And managers and architect roles can make considerably more than that. So it's a very well-paid position. There's a lot of demand. There's a lot of companies hiring for it. So that's why we're passionate about technical education on the data engineering side. This next statistic you see here, 50% growth in 1 year in terms of number of data engineering positions. And this is the fastest growing role in tech. So data engineering is a great place to be right now, and we're excited about it. And then the last thing you see here, unlimited time off. So typically what this means is that a lot of data engineering roles are remote work, and they come with flexible schedules and a lot of other benefits, health, dental, 401k, things like that. So aside from your top level compensation, the flexibility and the other benefits are great. So there's a lot of really good roles out there, and we're excited about helping people get into those roles. So today, more specifically, we want to talk about the Jupyter project for interactive computing. So Jupyter project is an open source project that has a number of different elements, and in particular, the thing that we use most commonly as data engineers are what are called Jupyter Notebooks. And we'll take a look at that in a little more detail in a minute. But just to give you an overview about the Jupyter project, it's a community-supported open source project that has a couple of different pieces. There's JupyterLab, which is the web browser-based interface for Jupyter Notebooks, and we'll take a look at in a little more detail at that in a minute. And JupyterHub is the sort of collaborative, the place for doing collaboration with Jupyter Notebooks. And then one of the biggest pieces of the Jupyter project for interactive computing is what are called notebooks. And we'll do a demo of this in a minute so you can see what I'm talking about. But notebooks are a great interactive format that let us package code along with interactive code along with instructions and narratives. They're collaborative, so multiple people can work on them at the same time. They're a great format for data engineers and data scientists to do reproducible research, to demonstrate the results of your building your data pipeline or your analysis. You can easily hand these off to somebody else that can then use the code and the data infrastructure you've written. And they're a great way to not only just to share your code, but also to give a narrative and a story to go along with it, which is really important. Okay, so why do we use notebooks? There's a number of reasons. First of all, notebooks give us like a self-contained interactive development environment, or IDE. You can do all your Python programming right in the notebook, run code interactively. You don't need any other software. They run in a web-based, browser-based interface, so it's super easy. You don't even need to download an extra IDE or another software. They're platform independent. You can run them anywhere. Jupyter is supported on all the major operating systems, all the major platforms. They're great for reproducibility in terms of research and analytical results. And as I said before, they're great because they let us package code with instructions and other things that let us tell a story about our code. So there's a number of reasons why, as data engineers, data professionals, that Jupyter Notebooks are one of the things that are one of the most common tools that we use on a day in and day out basis. And we'll do a demo here in a minute, and I think you'll see why. So just to give a quick overview of the demo, we're going to look at just an overview of Jupyter Notebooks, and then we'll take a look at a notebook that goes into some more detail with Python and Pandas. Pandas is the very powerful data manipulation library that's very common for data engineers and data scientists. And then at the end, we'll tie that in with BigQuery, which is the Google Cloud Unified Analytics platform, database and analytics platform. And we'll show you how easy it is in a notebook context to use the tools that Pandas gives us to write data directly to BigQuery. Before we do the demo though, I'd like to talk a little bit about more about data engineering and I'm sorry. Let's see. Actually, let's go ahead and do the demo, and then I'll talk about data engineering paths in a little while. So, give me a minute here to switch to my VS Code, and we'll take a look at this notebook. Okay, so this is Microsoft VS Code. This is the interactive development environment that we recommend in DataStack Academy that all of us use commonly on a day-to-day basis. And one thing that's great about VS Code is that it comes out of the box with really, really good support for Jupyter Notebooks. So what I have open right now is the Jupyter Notebook. So you can see that what's going on here is that we have text, blocks of text and code mixed in. Jupyter Notebooks are great because as I said, they let us package code and comments in a nice, neat format. They use this language called Markdown, which is a very lightweight formatting language that gets automatically rendered into HTML. So if you're familiar with GitHub at all, Markdown is very heavily used in GitHub. So Markdown gives us a number of common formatting elements like list ordering, ordered and unordered lists. Let's just do links, block quotes, code blocks, a number of different common formatting elements. And you can see here, this is the view, the editing view. And then when this gets rendered, you can see the formatting gets applied automatically. And you can see how easy that is and how beautiful the formatting is for these notebooks. So you can already get an idea of why we use these so commonly. Here there's a brief note on virtual environments, which are something that we use as Python developers, we use all the time. A virtual environment is a tool that lets us set up different versions of the Python interpreter and package dependencies on a project by project basis. And why that's useful is that if we didn't do that, if we didn't have virtual environments and we were trying to, we had multiple different projects at different applications that we were developing, and we were trying to install different versions of packages and use different versions of the Python interpreter globally on our system, we would inevitably quickly run into conflicts, and those would be really hard to manage. So virtual environments are a great tool because they let us manage those conflicts and avoid those conflicts so that we can work on a number of different projects and do that easily and seamlessly without having different version conflicts. Okay, so let's get a little more into details of Python in a notebook and specifically Pandas. So as data engineers, Pandas is one of the libraries, the Pandas libraries that we use all the time. Pandas provides a number of very powerful tools for reading, writing, manipulating data. So as data professionals, data engineers, data scientists, Pandas is something that we use all the time on a daily and hourly basis. So I'm going to walk you through some different steps of some different things we can do with data in Pandas, and you can see why we use Pandas so frequently. Okay, so what we're going to do here is work with some airport and some route data. See here, I have a CSV file, a comma separated value file that has some info, some data about different airports. So what we're going to do here is use Pandas to load from that CSV file, and then we're going to do some data manipulation in a couple of stages, and then we'll write the results out in a couple different formats. And so you'll see the details of that in a minute. But first thing we need to do is do a couple of imports and tell Pandas where our files live, and then we can load the data from this airport CSV. So Pandas provides this great, very powerful read CSV function that in one statement, we can grab the data from this airport's file, read it into a structure called a data frame, which is what Pandas lets, one of the data structures that Pandas provides us for working with data. And you can see when I run this, this is the first few lines of my data that I've read in from the airport CSV. Pandas provides us this nice summary view. So you can see quickly, without having to write more than a couple lines of code, we've already been able to load some of our data. So that object goes in, that data goes into an object called a data frame, and data frames are two-dimensional. They're organized into columns and rows, and that structure reflects the common tabular format that we see in a lot of database systems. So when you're working with Pandas and using data frames, Pandas makes it easy to change formats because it already keeps up with your data in that two-dimensional format that you're probably going to eventually write it to a database in. So here's a little sample of one of the many utility functions that Pandas provides. So this is what we call slicing. So Pandas provides us this nice, neat syntax for, we have all our data loaded in a data frame, and let's say we want to get just a few rows from the middle of this data set. The slicing syntax here, let's just get the first 5 of the rows from the middle and the first, second, and third columns. That's what the syntax is doing. So you see here, when we do this, perform the slicing operation, we get just a few rows and a couple of columns from our larger data set that we loaded before. This is something that in a language other than Python or using a tool other than Pandas, this would involve a lot more than a single statement. There'd be many lines of code. So this is why we love Pandas. One of the many reasons, because it makes these sorts of operations really easy. And as data engineers, when we're constantly having to quickly load data, get a view of what's in our data set and do some manipulation, Pandas provides a lot of tools to make that easy. So let's look at some other examples of some utility functions and some of the things that Pandas provides to make it really easy to get a view of our data. So we have this airport's data loaded in a data frame, and there's this info function that gives us this nice summary view of our data frame. You can see just with a single function call that we get some information about the size of our data set, number of columns, the data types in each of the columns, the memory usage. And this is, again, one of the many super useful things that Pandas gives us, because just with a single function call with this info function, we already have a lot of information about the data set that we've read in. So another even more powerful thing that I'd like to show you now is to sort of build on this idea of utility functions. There's a package for Pandas called Pandas Profiling that if we load it, it lets us generate these HTML formatted, these beautiful interactive data reports, these profile reports. So we can run this profile report on our airport data frame that we've already read in. And you can see that this profiling report gives us data about the individual columns, statistical correlations, variable interactions, statistics about missing values. It gives us a sample first and last rows, so we can see our data, see a quick view of our data. There's just so much that we can get just with this with this report that we can quickly and easily run, and that renders in this notebook format. So this is just yet again another one of the many powerful things that the Pandas provides. That as data engineers, we make use of this all the time, because when we're working with some data and we have some new data that we're doing some exploratory analysis on, it's really important that we can quickly get a view of the structure and content of our data, and Pandas, utility functions, and these profiling reports let us do that really easily. Okay, so next, let's take a look. Now that we have this airports data loaded, another very common step in data engineering, data science is a data cleaning step. So what we're going to do is just a couple of steps here in this part of the demo. Basically, we have our airports data frame. This code, when we run it, will drop a couple of columns. It'll drop the latitude and longitude column that we originally had in our data frame that you can see up here at the top. Let's assume for the time being that we don't need this latitude and longitude information, so we want to drop that. So Pandas, the drop function lets us do that quickly. And then when we do that, we can update, we can also remove some rows and update the index. This is a really good example of the kind of thing that as working data engineers, we do day in and day out. And again, that Pandas provides us a lot of really easy functionality for. Just with a couple of steps, we've been able to clean our data, get it into a different format. This is something that, you know, as a data engineer, we do often multiple times a day. And so you can see how much functionality Pandas provides and how easy it makes it to work with relatively complicated things with our data that, again, in another programming language or with another tool would take a lot more than just a couple of lines of code. And then here's an example of doing some filtering. So Pandas provides this really easy syntax. So what we're doing here is from our airports data frame, let's say that we want to select the rows that don't have any missing values. So these not in a functions let us do that quite easily. So this is yet another example of one of the many built-in Pandas functions that makes it very easy to manipulate, filter, get different views of our data to see exactly what we need and do it quickly and without a lot of work, without a lot of code. Okay, so next let's look at, now that we've read some data into our data frame, a very common operation is at some point, once we've done some manipulation, we're going to want to write that data out. So we read the data in from a CSV file, comma separated value file, which is basically a spreadsheet. So let's say that we want to, after we've done this manipulation, we want to write to, for example, to a JSON format, which is a slightly different format. So Pandas, yet another thing that Pandas makes really easy is it provides us this function called toJSON that, with a single statement, we'll take our data and write it to a JSON format. And we can see now this file, we started originally with our airport data in CSV format. And after running this toJSON function, we now have the same airport data, but in a slightly different JSON format. And there's a number of different formats, JSON, Parquet, a number of common data formats that Pandas provides built-in functionality to write to. And so yet another example of something that Pandas makes really easy. Okay, next. So now we've looked at some data cleaning, some data manipulation, writing in different formats. Now let's take a look at something that's really common in data engineering, data science, which is joining and grouping, joining data and then grouping and aggregating. So we started with some data in some airport data from a spreadsheet, but we also have now another spreadsheet that has some route data that has information about airlines, source airport, destination airport. So let's say that we want to combine these two files, these two tables, the airports and the routes data, and get some insight into the routes using information from both the routes and the airports file. So we already loaded our airports data before. So now we're going to do something similar and load our routes. You can see once we do this, once we use the read CSV function again, we load this route CSV, and now we have a data frame that has this route data that's been read in from our spreadsheet. And so now we have two separate data frames, one with airport data and one with route data. Okay, so let's say that we want to get some information about this data, this data once it's been combined. This is a very very common operation. So like just hypothetically, like what we're going to do here is, let's say that we're interested in, we want to combine this airport and the routes data because we want to get some information about which airports are biggest in terms of the number of routes that start from that airport. Okay, so we have two different data frames and we want to combine those into a single data frame so that then we can do some further operations on the combined data frame. So Pandas provides this merge function that lets us do that really easily. And in database terminology, what we're doing here is called a join. There's a number of different types of joins. In this case, we're going to do an inner join. There's a link here if you want more details on that. There's there's a number of different join types, and the details, there's a lot of details, but just know for now that this is one of the many ways that we can combine two different tables or two different data sources. So you see here, after we run this merge function, that the result is that now we have information from both of these data frames that are combined into one data frame. We have airport information, the airport name, city, state from the airport data frame. And then we also have the routes information from the routes data frame, source, destination, airlines. These have been all combined into one data frame. And you can see that each one of these rows corresponds to a single route. So for example, for the Alturas Municipal Airport, there's two records in this combined data set because there's two routes that initiate from that Alturas Airport. Okay, so we've combined this data now, and what we're interested in doing is getting a count of the route initiations from each of these airports. So we're well on the way to doing that because we have this combined data, but we need to do a couple other steps to get the information that we're really trying to get out of this. Okay, how can we do what we need? How can we get a count of these route initiations on this combined data? So Pandas provides a number of functions that let us do this easily. So the first thing we need to do is group this data by the airport, so that all the rows for each of these airports go into their own group. Once we've done that, we can apply an aggregating function. In this case, we're going to count the number of the routes in each one of those groups, and we'll see the details in a minute. Okay, so you see, before we do that grouping, each one of these rows corresponds to a different route. So we're going to group that, and then we can apply some aggregating functions, and we can we'll be able to get a route count. So there's a couple of steps we're going to do. So we're going to use Pandas group by function, and we're going to group by the airport to sort of collapse this this combined data set down. And you can see what happens. What happens when we do this grouping is we go from a data set that has multiple rows or multiple records for each airport into now a data set that has a single entry for each airport. And we've created this new column called route count that counts the number of routes that initiate from each of these airports. And we've also sorted, you can see initially when we first combined this data, it was sorted alphabetically by the airport name. But after grouping this and applying the aggregating function to get the route count, we've also resorted this. So with just a couple of Pandas statements, we've now reshaped our data, we've created a new column, and we've resorted. And so now we've reorganized our data frame here to give us basically a listing of the top 20 airports measured by route initiations, and that route count comes from the count aggregating function that we used above. Okay, so this is a very common thing that we do in data engineering, data science all the time. This is an example of what's called a split, apply, combine strategy, and this sequence of joining, grouping, and aggregating is something that is done very commonly, and that Pandas provides a lot of great tools for. Okay, so now we have this updated data set and with the top 20 airports. And we wanted, the last step that we want to do here, and this will give us another, some more of an idea of why notebooks are so great in terms of interactive format. So most of what we've done up to this point is data engineering, where we're combining data, applying a sequence of operations. But now that we have this updated data, we want to get a visualization so we can have a nice, single view of that will give us some insight into this data. So we're going to use Plotly, which is a very, very, very powerful plotting library, and we'll use this geo scatter plot. So basically, now that we have this combined data frame with the root counts, we can give that data frame to Plotly and give it some parameters and plot this in this geo scatter format. And you can see the result of that now is this really beautiful interactive plot that we can hover over. The airports are plotted with a bubble by their size in terms of route initiations, and we can hover over this and get the details. And again, this is something that Jupyter Notebooks, this is why we love working with Jupyter Notebooks, because they let us do these things easily and interactively, and we can combine these visualizations along with our code and our commentary. And so it makes it really easy to walk somebody through our steps of analysis and to share the results that we've gotten from doing some data engineering, some data science. Okay, so we've gone through a series of Pandas operations, and we visualized the results at the end. Now, the last thing that I want to do really quickly in this demo is just to show you, to tie this into what I'll call here data on the cloud. So another one of the many things that Jupyter Notebooks let us do and interface with easily is there's connectors to all sorts of cloud services and storage. In this case, we're going to use the connector to Google BigQuery, which is Google Cloud Platform, their integrated database and analytics engine. And Pandas provides a function that will automatically take the data frame that we created up above and write it directly to a BigQuery table. So we tell the Pandas function what our Google project is. We give it a couple of pieces of information here, and then we call this 2GBQ function. And if you'll notice here, this is just one function call, and there's a lot going on behind the scenes with this, because Pandas is inferring what we call the schema or the format for our data. We don't have to specify that explicitly. It infers that from the shape of our data frame. And then after we run this function, that data gets written to BigQuery. So I'm going to switch here real quick to my Google Cloud Console, and I can show you the results of, now that we've called that Pandas function, our airport data that was read in from our spreadsheet, and which we read into a Pandas data frame, has now been written to a table in BigQuery, and we can see that here. We're getting a preview. And again, I'd just like to point out, how easy and straightforward Pandas makes this with a lot of these built-in functions to do things that in a lot of other languages or a lot of other with a lot of other tools would take a lot more than just a couple lines of code. Okay, so this gives you some idea of start to finish, a kind of basic some data manipulation with a visualization at the end. And this gives you a good idea of why Jupyter Notebooks are so powerful, so common in the world of data engineering and data science, because they let us do so much in this really neat interactive format, and they make it easy to share our results with other data engineers, data scientists, or data analysts. And so I think this gives you a good idea of why, for data professionals, why Jupyter Notebooks are so common and indeed just have become ubiquitous in the world of working with data. Okay, so let's go back to slides here. I'd like to talk a little bit, now that we've done our demo, I'd like to talk a little bit more about DataStack Academy and data engineering and learning the skills to become a data engineer. So there's a couple of paths in general with technical education, and in particular with data engineering. One of those is self-learning. So this path is typically Typically better for somebody who already has some technical background. I mean, it could work for anybody, but it's in general works better for people who already have some technical background. So there's a number of different things that you can do on the self-learning path. One of those you can see here, the first thing on the list is follow the cloud certification paths. All the major vendors, Google, AWS, Microsoft, all have their own certification, excuse me, their own certification tests and learning paths. Those are a great thing to help you frame your own learning, and also getting that certification, that credential at the end really helps you distinguish yourself in a crowded job market. So we recommend those a lot. Another thing we definitely recommend is to build a portfolio on GitHub. When you're learning and you're starting to do projects, this is one of the best things you can do for yourself. Is anything you do, make a repository for it on GitHub. Post your code. When you go to apply for jobs, this is something that every single, excuse me, every single employer will do. Is when you're applying for a job, you will be vetted in terms of people will go look and see what code you've written, what projects you've worked on, and GitHub is pretty much the place to do that. So that's why we recommend GitHub so strongly in terms of your own learning and when you're working on projects. Some other resources that are similar to that is, when you're learning, especially tackle real world projects. There's so many good resources out there, like for example, Kaggle, which is a data science and data engineering website that has free data sets, interactive tutorials, a number of different resources. DataHub.io is another one. There's many, a lot of these, and there's more of these that are linked in the notes, the notes to the slides, which we'll post after the webinar. But tackle real world projects, work with real world data. There's so much free data out there. There's so many good interactive tutorials. Even as a self-learner, there's a lot of easy and free things that you can do to start learning immediately. There's a lot of other online resources. YouTube is great for technical education. Twitch, there's so many, so many good blogs, so many good YouTube channels. Definitely make use of those resources, because there's so much free and inexpensive content and material out there. And there's also paid online programs, particularly in the kind of the smaller format. I think we're all familiar with Coursera, Udemy, these types of sites, and those are typically a lower cost barrier. A lot of times you can take a course for maybe $10 or $50, and those courses are something that you can do in a few days or maybe a week or two. And those are, a lot of times, those are definitely worth that small investment, because the content is all organized neatly, and it'll you'll get to walk through that information with different coding exercises. So that's definitely another resource to take advantage of. The other learning path that I want to talk to you about, and this is something that we're involved with DataStack Academy, is the bootcamp style. So at DataStack, we have a data engineering focused bootcamp that's a 17-week curriculum. Bootcamps have some different advantages. Obviously, bootcamps are a more of a time and cost commitment, but the focus of the declared attention can be really, really helpful in structuring your learning. Self-learning is great for a lot of people, but it can also be hard. We all have busy lives, so it can be really hard to keep the initiative on that. And a boot camp is set up so that you have a regular daily and weekly schedule, and that helps you stay committed and stay learning every day, every week. A big part of the boot camp model is interactive coding and pair programming, coding with other people, and working on the kind of projects that you'll work on in the real world when you go get a job with a company working with data. Another big advantage with the boot camps is the instructor time, and this is something that you might get a little bit in some of these other less expensive paid online programs like Coursera, but if you're doing purely self-learning, you won't get any hands-on time with an instructor at all. And this is a big plus in the bootcamp style of learning, because having access to an instructor and somebody that can help you organize your learning in that way and answer questions can be extremely productive and extremely helpful. Career services are another thing that the boot camps provide that we provide at DataStack. So that includes internships. We help match you with a company that's going to be a good fit. That's the kind of company that you want to work with. And this is another big advantage of what you're getting with bootcamp style. Now, bootcamps obviously aren't for everybody. It's definitely more of a time and cost commitment. So that's a decision that you really want to think through. Again, for people that have more of a technical background, sometimes the self-learning path can be really productive. But for a lot of people, especially if you don't have as much of a technical background, or if you're making maybe a mid-career shift, the bootcamp model can be really effective, and it's something that works for a lot of people. Okay, so our website is datastack.academy. You can also go to datastackacademy.com, but datastack.academy is a URL. Real quick, I will show you. I'll show you the website. If you go to datastack.academy, our website has some of these information about data engineering as a career, what data engineers do, more details about the structure of our course, the bootcamp, length, the weekly cadence, a lot of information about the exact tools and skill stack that you'll learn. There's a lot of information here, tuition information, payment. There's information about our career services and mentorship. So if you go, at the top here, if you click Get Started for free, you can click to apply. If you click to get started for free and you put in your email address, we have the first 2 chapters of our 10-chapter course available for free in GitHub. So if you click Get Started for free and put in your email address, you can get access to those first 2 chapters. There's webinar registrations. You can also click to schedule a call with Param, who does our mentoring. And if you click that schedule a call link, that will go directly to his calendar. You can schedule a one-on-one call, and he'll be glad to answer any questions you have, talk to you about data engineering in general and our course more specifically. So yeah, go to datastack.academy. There's a lot more information there. That should answer a lot of your questions and give you an idea of some of the details of the curriculum. There we go. And then lastly, we're very focused at DataStack on industry-driven curriculum, because it's very important for us to teach you the skills that you're going to learn in the real world. So we're very, very heavily invested in Google Cloud Platform. We think it's the best set of tools out there. It's a lot closer to a lot of the underlying open source tools. So here you can see the 10 chapters in our curriculum. It starts with basics of Python, SQL databases, goes through Pandas, APIs, through 10 chapters. We start with data engineering fundamentals, go into big data, data pipeline orchestration. There's a heavy cloud component. A lot of our curriculum focuses on cloud data engineering, because that cloud is the way of not only of the future, but the way of the present now. And serverless architecture, which is the modern way of designing applications and data pipelines in the cloud world. So our curriculum, this 10-chapter curriculum, represents many decades of industry experience between all of us on the team that have designed this. And we've designed it because we think this represents the best combination of skills for you as a data engineer to get a job. So again, if you go to the website, there's more information on this, and you can get the first couple of chapters of our course for free. And then, yeah, datastack.academy. If you have any questions, there's a lot more information there. You can schedule a call to talk to one of us to get some of your questions answered, and get an introduction to detailed introduction to the curriculum. So, yep, go to DataStack. There's a lot of information about data engineering career and about our curriculum, and that's a good place to start. And then if you have questions, you can schedule a call. One of us will be glad to answer your questions and talk you through the decision of learning about data engineering, potentially becoming a data engineer, and thinking about taking our boot camp. So yeah, go to DataStack Academy. There's a lot of information there, and we're happy to answer your questions. Okay, so me go back to my Zoom here. Okay, so that's it for the presentation portion. Oscar, I see you in there. If you have any questions, let me know. Today is more of a pre-recorded webinar, but I'm going to hang out for a few minutes, and I'm glad to answer any questions. So if you have anything you want to ask, put that in the chat window, and I'll be glad to answer. And if you think of things later, like I said, DataStack.academy, that will help answer more of your questions. So if you have questions, put them in the chat, and I'll hang out for a few minutes and answer any questions that we might have. Thank you. Okay, thanks, Oscar. I see your question. That's a good question. Let me see. That might be something I have to ask Parham. He might be more familiar with the details of that. Unfortunately, Parham is out sick with COVID this week, so he's not available at the moment. Let me take a look though, and see if we have details of that on our website. Let's see. So I'm not, Oscar, I'm not sure the details on that, but I'm going to put, so if you email that's my email. I'll ask Parham, when I talk to Parham, who unfortunately is out sick today, I'll ask him for some more of the details on that. If you want to leave me your email, I'll be glad to ask him more about that and get back to you. Does that sound good? Yeah, either give me your email here, or if you don't want to put it in the chat, if you just email me guy@datastack.academy, and I'll get with Parham on that and get you some details on that. Thanks for your question. I appreciate it. Okay, well, Oscar, if you don't have any more questions, I think I'm going to wrap it up. Thanks for joining in. So we're going to post, we post these on our YouTube channel, the pre-recorded ones, and then also we'll post the slides, and there's a lot of more detailed notes about the different surveys and the information we're using. So feel free to check that out. There's a lot more good information there. And yep, shoot me an email, and Parham and I will get back to you. It might be a day or two because unfortunately, like I said, he's sick. Yep, if you shoot me an email, one of us will get back to you and let you know the details on that. Thanks, Oscar.